Welcome to the Omega Coding Club. I am Rishil Bharadwajal. Today we will be learning about functions in C programming. We will cover the topic using three major questions. What is a function? Why do we use a function? And how to use a function? A function in C or any other language is a set of statements that perform a specific task whenever the function is called. A simple meaning of a function is define the code once and use it many times. The benefits of using a function are as follows. The function provides modularity. In large programs, debugging and editing tasks are effortless with functions. The program can be modularized into smaller parts. A separate function can be developed independently according to the need. We have completed the parts of why do we need a function and what is a function. Before we get into the part of how do we use or create a function, let's learn the types of function that there are. First is a built-in function and second is a user-defined function. Built-in functions are functions that are already present in the library by default. For example, your codes like printf or printf, scanf, and str length, str copy, and others, or str concatenation. All of these functions already have specified functionalities or specified outputs to be given whenever they're called. So these are, as they're already present in the library by default, the user is not required to create the function again and again to use them. So these type of functions are called as built-in functions. So now the question is, what is a user-defined function? Now let me write a small code. For example, int a like this, int a and int b. Then let's take one more variable as sum. Let's give the value of sum to be a plus b and then return sum. As you can see, now this is the basic structure of a function in C. I'll get into a more generalized form of the function in a while, but let's just for this understanding, let's assume that this is a working function. Alright, as you can see, this function called as add takes two inputs a comma b and returns a value of sum. So as this has been created by the user, these are called as user-defined functions. Each function has three major parts. First is the function declaration, in which you give the data type of the function, the name of the function, and the parameter list. In our case, the data type of the function is int, the name of the function is add, and the parameter list consists of two variables, that is int a and int b. As we are writing the function in C programming language, we have to make sure that the function name as well as the parameters have a defined data type and cannot be left empty. So when you have written only the function name, the data of the function, and the parameter list, it's called as a function declaration because it's just declaring the function, but there's no body to the function. Now let's write a body to the function. That is called as function definition. So in which you'll just write the data type of the function name, and of course you have to write the parameter list, and then you'll open a flower bracket. You open a flower bracket to tell that you're writing the body of the function. So now the function being add, it's of course makes sense to add the two integers or two numbers you've taken, that is in our scenario a plus b. To store that, we'll take another variable as 0 or no, as sum. Then we'll make sure that sum equals a plus b. We'll return sum. Now why do we have to return sum, or why do we need a return statement in the given function or in the considered function? It's because we can observe that the data type of the function is int, and int is such a data type that requires a return statement for it to fulfill the program or the function. For example, there are functions called as void and non-void functions. Void functions are those functions without a return statement. For example, if you write a function like void main, we can see that we can just give printf and then like print hello world, or print hello world. Let's try to just run this. You can see that hello world is printed, but what if we don't give a return statement to the int function but try to call the function? All right, so we'll try to call the function in the void main because that's your major part of the program. That's your main part. So we'll take a variable as result equal to 0. Alright, and int a to be 10 and int b to be 10. Then we will store the function in value, because we have to print out the value again, and then we'll make sure that we add a plus b. So if you just give printf, then %d and res, let's see what happens. It gives an error telling add must return a value. Because the data type of the add function is an integer, we have to return an integer to it, else the program will give an error telling there's no return statement even though it's a non-void function. So let's try to run this now, and then there you go, hello world and 20. Hello world is because we have already printed hello world here, which is not required in our scenario. Let's just remove that and then run the same code again. You can see 20. So what we have done so far is we have declared a function, then we have defined the function with all our variables, our parameters and etc. Let's just get to know what a parameter and an argument is. A parameter is whatever you enter in the function header. Alright, it's like if these parameters are met, only then the function can run. What is a function call? A function call is where you have used the function to get to make the set of codes written previously to run. So here the function call is add a comma b, and the values of a comma b here are called as arguments. Just to put all the things I told so far in a better manner, line 1 or the comment 1 you can see is called as the function declaration, because we've already mentioned the function name with its respect to data types and its parameter lists. Anything that is written inside a function header is called as a parameter. For example, in this function you can see int a comma int p are your parameters. The major reason to use parameters is telling that only if these parameters have certain and specific values that are supposed to be there, only then the following lines of code will be executed. In line 3 you can see that we have called the function add a comma b. In this, while calling a function, you don't use any of the data types mentioned. You already have the values predefined. You just have to make sure that you call the function with the respective values or variables you require. So in our case, it's just add a comma b. Here you can see that a comma b is an argument for the given function. So your int a comma int b from line 2, take the values of a comma b from line 3 and then give you the return statements and the value of sum, which is again printed in the form of res. Just a quick recap of whatever we've done so far. We have learned what is a function, why do we need a function, and how to write a function. And then we learned about what is a user-defined function, what's a built-in function, how to define a function as that's a user-defined function, how to code a function, then what are parameters, what are arguments, what's a function declaration, a function definition, and then how to call a function. So we've done all that so far. And then we learned about what's a void function, what's a non-void function, and how they work, what is the use of a return statement, and how does a return statement depend upon the data type you use, if it's like a int data type of the function or a void function. Now there's one more type of function that's called as recursive function or recursion functions. Any function that happens to call itself again and again unless the program satisfied a specific condition, then it is called as a recursive function. So we understood the theory behind what a recursion function or a recursive function is. Now let's try to put it into a more practical knowledge by coding a certain program with a recursion function. I hope everyone knows what a factorial of a number is. A factorial is a function that multiplies a number by every number below it till 1. So if I ask you what's a factorial of 6, I mean nothing but 6 into 5 into 4 into 3 into 2 into 1. Now I hope everyone knows y is till 1, because any number multiplied by 0 is always going to be 0. So alright, so we got to know what we're going to do right now. Now let's try to write a code for factorial of a number using recursive functions. Let's define the function first as int fact with a variable of n. That's going to be our limit. Now let's define the function int fact of int of n, open flower brackets. If the value is greater than or equal to 1, then return n into fact of n minus 1. I will explain the code in a while. Just till then, just listen to what's happening. Else return 1 and we close the function. Now let's write the main function. Let's make it as void main. Then of course we need a value of n. Printf, enter a positive number. Positive number. Then semicolon. Then scanf, because we need to take the value that's going to be given by the user, comma ampersand of n. Then printf factorial of the number is percentage d, and comma, we'll call the function of fact of n. Simple. Now let's see if the code works. Control S, save the file. Control F5 to run the program, and there are some errors. So what is the error? Okay, now I will get into like how to remove the warning of scanf. Until then, we'll just use scanf_s. So enter a positive number. Let's enter 5, and the factorial number is 120. That's correct. So, alright, we got the output. Now let's try to understand what's happening in the code. First of all, the first line that's mentioned is your function declaration. Then this is your function definition, because you're explaining what's happening in the function. Now let's imagine the value of n to be equal to 5. Alright. So what's happening in the return statement is, first the value of n is 5, then it again calls itself, but here the fact of n minus 1 is 4, so 5 into 4, then again 3, 2 and 1. Alright, as soon as it becomes 5 into 4 into 3 into 2 into 1, then again fact of n minus 1, which is fact of 0, but n is not supposed to be less than is not supposed to be less than 1, right? It's always supposed to be greater than or equal to 1 for this line to run. Therefore, because that is false, it goes into the else, it just returns 1. So therefore your output is 5 into 4 into 3 into 2 into 1, which equals to 120. That's the reason when you call the function fact of n, that is fact of 5 in our scenario, you get the value of 120. So I told you that I would tell you how to remove the scanf errors or warnings, right? Like it tells CRT sector no warnings. One thing you can do is you can just type hashtag define with the error completely by itself and then run it. It's gonna run fine. Enter a number, you enter 10, it shows 10. What if you don't want to write this error name every time? Then there's one more way that you can do it. That's like go to project, then go to learning properties, Control F, like in C++ preprocessor, Control F here and then OK, and then you can just run it, and it gives you the output. The major reason that scanf is said to be unsafe is that it stores values without any regard to its memory allocations and sizes, which can potentially write to memory reserved by other values or variables. Due to this, the compiler tells you to use scanf_s, which is supposed to be a lot more secure than just scanf. This error or this behavior of scanf is called as buffer overflow. I hope everything was clear in today's session. Hope to see you in the next session.